All right, let's get started. This is going to be our manipulating trig graphs and finding the period homework help video. The first part of this asks us to use our calculator to graph each using radians. I'm going to show you guys a couple techniques to really help you do this with just your calculator. And then we'll talk about transformations on the second half of this homework. First thing is that I want to guarantee that my calculator is in the right mode. So I press mode right there next to the second button, and I'm looking to be in radian mode. I can tell that this is in radian, one, because my horizontal shift is clearly in radians, but also just because the problem tells me graph each function using radians. So I'm definitely in radians. If I see a number like 90 or 180 or some like degree measurement right here, then I'm probably in degrees. But with graphing, definitely just look at maybe what your shift is. Also, the x-axis here is clearly labeled in radians. You can see all those pi values strongly associated with radians there. All right, the next thing is I want to change my window to match what I'm seeing on this piece of paper. So I press the button window. It's going to bring up these options here. The x minimum. How far does this go over on the x-axis? It looks like my furthest over grid line is negative pi over 4. So I type that in exactly as you see. Negative pi over 4. It's going to fill in a decimal, but that is equivalent to negative pi over 4. The furthest I see it going over this direction is 2 pi. Maybe it goes 1/4 of a pi further. So maybe we want to do a little more than 2 pi. So 2 pi would be equal to 6.28. Maybe we round that up to 7. And maybe we round this one down to -1. It looks like we can see it a little bit further than negative pi over 4 here. Now the scale, this is actually pretty important. We don't talk about the scale too much, but if we make the tick marks match what we're seeing here, we're going to have a much easier time graphing. I can see that one box is equal to pi over 4, and I just have to look at the first label to know that. So each of these boxes is pi over 4 radians. So I want to just type in pi over 4, and I don't want to round that or anything. I want to just leave that whole decimal. The x or the y-axis goes as low as -6 and as high as 6, and has tick marks every 1. Another good idea, so that I actually get these grid lines, is to press second format right there, and then turn my grid on. And you got some options. We've got grid dot and grid line. Either's fine. I'm going to go with grid line. Some of the older calculators only give you that option. All right, now we're ready to plug this in. When I plug this in, I'm going to do 4 cosine 2. Now I need to type in a theta, but in reality, this is just my independent variable. You can see the theta on this button here. When we press it, it just puts it in an X, but we'll know that that actually means theta. And there is a theta there to sort of remind you. This is just our independent variable. Minus 7 pi over 4, close parentheses, plus 1. And let's take a look at this graph now. So look how similar my window looks to that graph in terms of like how the axes are set up. Really, really similar. So this is going to make it easy to graph. I'm going to have to do this just sort of kind of looking back and forth. Let's see, I'm going to want to point here. That's 1, 2, 3, 4 units over. 1, 2, 4. So yeah, a peak about every 4. Minimum of -3, a maximum of 1, 2, 3, 4. I think I'm ready to graph this. So it looked like about a peak there. 1, 2, 3, 4, 4. Right in between, it was down at 3. And connect it with this wave shape. Oh man, it's doing so good. let's see how that matches up decently. That's good enough for our purposes right now. If we want exact values, we can always do this. Second, trace, enter, and now I can calculate an exact value anywhere on this line. If I wanted to know exactly what the value was, I don't know, pi over 2, I could just type it in and get that value there. All right, then I can scroll along to get more values, or just press trace and scroll along to get values. Don't know what I just did there. Oh well, on to our next thing. We'll call that good, since that was pretty long to graph that one. Just make sure you're making your windows match. Let's move on to this side. Using radians, find the amplitude, period, domain, range of each. Also state any horizontal or vertical shifts. I did not include any vertical shifts. I think I forgot to hit the button for that. So all the vertical shifts are 0. But if there was a number at the end, like a +2, that would be the vertical shift. But none of these have any vertical shifts. Let's see. Amplitude. Amplitude is always just this number right in front of the trig function. So the amplitude of this wave is going to be 5. Period, we've got a formula for period. It's 2 pi divided by b, where the b value is the number right there in front of our variable. So this is 2 pi over 5, and that can't be simplified. Domain. For every single one of these, the domain is going to be all real numbers. All right, I don't see, the only one that has a restriction that we know of so far is tangent. Sine and cosine don't have any restrictions on the domain, so the domain's all real numbers. Range is the kind of tricky one. All right, so the range is normally from -1 to 1, but this now has an amplitude of 5. So that's going to go -5 is less than or equal to y is less than or equal to 5. It's going to range from -5 to 5 as it goes up and down. If there was a vertical shift, then these numbers would change as well. Like if I did a +2, then the range would be -3 up to 7, because of the +2 would affect the range. All right. Horizontal shift. This one's also a little tricky. It has its own formula. It is h divided by b, where h is that number right there, but I want to flip its sign. So if I see a plus here, we got to know that the formula already has a minus in it. So the only way to get a plus is to make our h negative as well. So this is now negative pi over 4 divided by 5, which equals negative 5 pi over 4. Or we could say it is shifted left 5 pi over 4 radians. And vertical, there is none, just like we said. All right, we'll skip this one, do a couple more, maybe 3 more. Go a little bit quicker. Number 7, amplitude is 8. The period's next. Period is equal to 2 pi divided by 8, which equals pi over 4. Domain is all real numbers. The range, double stroke R, the range is from -8 up to 8 because of that amplitude shift. Vertical shift, none. Horizontal shift is equal to h over b, so negative 5 pi over 4 divided by 8, which equals negative 5 pi over 32. I'm going to copy dot flop that, or we could just say we go left 5 pi over 32 radians from our parent function. Make that 5 look a little better. 5 pi over 32. All right, skip this one. Let's try number 9. Switch up the color. Amplitude is 6. The period. So this is my B value is 1/8. If I see theta over 8, I could pull the theta off the top and leave a 1 behind, and it would be 1/8 times theta. That was our equivalent. 1/8. Multiplying something by 1/8 is the same as dividing it by 8. So 2 pi divided by 1/8. We're going to copy dot flop this. I'll actually show it. So it's 2 pi over 1 times 8 over 1, which equals 16 pi. Domain, all real numbers. The range is -6 to 6. The horizontal shift is h over b, or negative pi over 2 divided by 1/8, which is -8 pi over 2, if we copy dot flop that, or -4 pi, or left 4 pi radians. Vertical shift is none. Let's do number 12 for our very last one, since it we'll have all of our standard values, except for it's got a b value of 2 or of 5. So the amplitude, if nothing is written, is 1. The period is going to be 2 pi over 5. Domain will be all real numbers. Range will be from -1 to 1. Vertical and horizontal shift are both none. So vert, none. Horizontal, none. All right. So let's see. Well, okay, h over b. H is 0. Yep. Okay. Okay. I think that's good for this homework here. And good luck studying for everything that you're studying for.